Okay, so this video will pick you up after you have plotted your points from your samples that you collected in the lab. So you should have your data table with your mass and volumes of each sample. And then you can see I've just plotted the data here. And what you should notice, right, is that there's two different groups of data. So you kind of have a few, points that are like up higher, right? And then you have a few points that are down here. And it's okay. You may have like, a few extra kind of down lower, just depending on how many samples you had. But you should be able to see like a clear division between the points that are following like my blue line and the points that are a little bit lower down on your graph. And remember, your points may not look exactly like mine because mine are just example points. Remember, I might not have had the exact same pieces as you did for your lab. So just go based on the points that you drew on your graph. And then what we're gonna do now is draw a line of best fit. And you can see, like for example, my blue line, we're always gonna start at 0. But we're not playing connect the dots. We are just drawing a line that pretty much kind of goes through like the middle of all those points. Okay, and then again, we have the same thing. We have our red line that goes through the middle of all those points. Okay, so you should pause here. Go ahead and draw your two lines for your, and I'm gonna change my color to blue so it makes sense. So draw your two best fit lines and then resume the video. Okay, so what we're gonna do now is calculate the slope of each line. So if you think back to algebra, remember our slope, we can find that by rise over run. Okay, so I'm just gonna pick 2 points on my graph. I think it's easiest if I start at 0, 0, because I know that's 0. And then I'm gonna pick another point, like this point intersects those squares pretty easily, like kind of right in the middle where those points connect. So I can easily see, my measurements. I'm not trying to guess. Like if I choose this point, then I'm kind of having to guess like between my spaces. So I'm just gonna find a point that intersects right in like that cross of the box. And so I'm gonna find my rise over run for this line. So if I'm starting at 0, I'm gonna rise all the way up to here, right? So that means 60. Make sure you go based on your numbers that you lined your graph with. I wouldn't wanna put, like, even though I only went up 6 lines, that's not the measurements that I'm saying my graph is equal to. So always want to put the number from your graph. And then we ran my over, I'm kind of intersect my space here, all the way over to this way, which is the 6. So my slope for this line is 10. If I want to find the slope of this line, again, I'm going to start at 0, 0, and I'm going to try to find... So maybe I could choose this point. It's not quite on that intersection of the two lines, but it's just a little bit under it. So I can probably, I can guess pretty good, I think. So I'm gonna do my rise, and I think it's just like, if I go all the way over, it's just kind of right below the 20. So I'm gonna say my rise is 19. And then my run, right, I went all the way over to right here, which is 7. And so if I type that in my calculator, 19 divided by 7, then you end up with 2.7. So the slope of my top line is 10. The slope of my line is 2.7. You need to do these same calculations on your lines because your slope will not be the same as mine because you have a different graph, you have your own samples, you drew your own line. So pause the video, follow the same steps that I did to find your two slopes. Question number 4 is asking us, could we use the points plotted on our graph to make predictions about other samples. Oh, wait, I forgot to finish number 3. Number 3 asks us, what is the slope? So why did I find the slope of this line? So if we think about it, what were we really measuring when we did our rise, right? We set our rise. Well, if we look, when we were measuring our rise, we're really measuring the mass. When we're measuring our run this way, we're really measuring volume. And so mass over volume is equal to density. That's how we calculate density. So really, all we're saying is we're saying the slope of this line is equal to the density. So if I have a line like the blue line is very steep, right? It's going more upwards. I can see my slope is higher. So that means this sample is more dense. Whereas my red line, my slope is lower, it's more flat. That means this is less dense. Okay, so for number 4, let's see what color I want to use, maybe orange. It asks us, how can we use the points to make predictions about other samples? So let's say I gave you another sample, and I told you it was the same as our blue sample, and I told you that the mass was 50. I knew the mass of that sample. What if I wanted you to find the volume? Well, you could, right? Because all you would have to do is just follow over at 50 until you intersect with this line, and then look down, and that's going to tell us our volume. So probably something like 4.9, almost 5, right? And then we could do the same thing. Let's say I told you that the volume of our red sample was 8, and I wanted you to find the mass. You could go up until your line intersects, and then we just go over, and maybe that's like 22 or so. So we can use our best fit lines to find other information about other samples, okay, that we may have in the future. Question number 5 gives us a picture. Okay, so it gives us 2 different particle drawings. It shows us 2 circles. One of the drawings has a lot of particles. Okay, so a lot of particles. One of our drawings only have, I think, 5 particles. Okay, so what this drawing is showing is it's showing us 2 circles that are the same size. So both of these pieces have the same volume. But we can see that this first sample has a lot more particles than the bottom sample does. So that means that this one has more mass, and this one has less mass, right? Fewer particles. Well, we know that density is mass over volume. So if we have a sample that has a lot of mass in the same amount of space, that means it's going to be more dense versus this sample that has fewer particles, right? That would be less dense. And so remember, sometimes we can think about density as like how heavy something is. So if we have a sample that is very dense, that means it's going to be very heavy. So it makes sense that there's a lot of particles in there. That's going to make it heavier. So question 5 is asking us which line, our red or our blue line, is going to be each of these samples. And all we really have to do is think, kind of connect. So we already said that a sample that has a high slope, right, is going to be more dense. So we can just kind of draw our lines, right, and connect. Our more dense sample with our high slope is going to be this drawing that has more mass, right, in the same amount of space, our more dense sample. If it's less dense, like our red line that has a smaller slope, it's more flat, that's going to match up with our particles, where we have fewer particles in the same amount of space. So use this information to help you finish answering your lab questions, and then follow the next step of directions.